So hi friends, today we're going to be solving Cambridge O-Levels Chemistry Paper 1 Multiple Choice, May-June 2024, Paper 12. And the grade threshold for this paper, you gotta have a 25 out of 40 to get an A. And this grade threshold clearly tells us that it might be a difficult paper because the threshold is low, it's about 25. So let's get started with the paper, and before starting it, I'd like if you guys choose your answers yourself before I tell the correct ones, because that's going to be a really good practice for you guys if you choose them before I tell. So let's get started with the first question, which says, which physical changes are both exothermic? So now the concept over here is about exothermic changes. Exothermic changes are changes which release heat into the environment, and it has to be a physical change. So let's think about the exothermic changes that release heat. The first thing I'd like to tell you about over here is simple physical processes like evaporation, condensation, boiling. For example, if you are boiling a substance, so what do you have? Initially, you have a liquid and you are turning that liquid into gas. So what's basically happening? Does a liquid have more kinetic energy or a gas? You should know that a gas has a higher kinetic energy. So what basically happening is the liquid is gaining kinetic energy to be turned into a gas. So it's gaining kinetic energy. It's gaining the temperature or heat. You are giving it heat. So that's an endothermic reaction because heat is going into the liquid to turn it into a gas. So boiling is clearly endothermic. Similarly, if you talk about freezing, what's basically happening? In freezing, you have a liquid and you are turning a liquid into a solid. So what's basically happening? Does a liquid more have kinetic energy or a solid? Obviously, a liquid has more kinetic energy. It has a greater temperature. So what basically happens is the heat is coming out of the liquid to make it into a solid. It's losing the kinetic energy. Okay? So that's what you have to understand. So over here we know, according to this, freezing is going to be exothermic. Why? Because heat is coming out of the liquid. Freezing is going to be exothermic. So clearly not option A, clearly not option B. We have to look for C and D. So now let's talk about condensation first. So what's happening in condensation? Condensation, you have a gas and you are turning a gas into a liquid. So what basically is happening is that heat is coming out of the gas. A gas has more kinetic energy. A liquid has less kinetic energy. So what basically happening is kinetic energy, or you can say not the kinetic energy does not come out, heat energy, thermal energy is coming out of the gas to turn it into a liquid. So the energy is coming out. That's exothermic. Exothermic means the energy is exiting or coming out. So condensation is clearly exothermic. So the correct option is going to be option C. Moving on to question number 2, which says, what is tap water? A compound. What do you guys think? Tap water is not a compound. Why not a compound? If it was a compound, it has to be H2O, a simple water molecule, but it's tap water. It's not distilled water. Distilled water is 100% pure, but a tap water is not pure. It has different elements, not elements, I'd say, different ions in it. So it's not pure, so it cannot be a compound. It's not H2O. A mixture of compounds and elements, well, that could be thought about. Moving on, a mixture of elements, not at all. You have H2O in tap water. How can it be a mixture of elements? You have a compound, an element, not this, not this. How can it be an element? You have H2O. H2O is not an element, it's a compound. So clearly it has to be option B. A mixture of compounds and elements. Elements can be different elements in it, like you have dissolved oxygen in tap water, O2, dissolved oxygen, and different substances, they can be elements. And compounds, you clearly have H2O, that's a compound. So elements, you can have ions in it as well, like sodium ions, like chloride ions. Sometimes you have fluorine in tap water, so you have fluoride ions as well, so there can be elements in it as well. Okay, moving on to question 3, which says, in which pair of particles is the sum of their charges equal to 0? Okay, the sum of their masses almost the same as 1/12 of the mass of a carbon-12. What do you mean by 1/12 of the mass of a carbon-12? What does the statement means? 1/12, people always confuse this, but you don't have to. 1/12 of the mass of a carbon-12. What does this 12 tells us? This tells us this carbon-12, okay, I'm going to explain this. Clearly try to understand this. This carbon-12 basically has, why is this 12 over here? Why is this 12 upon carbon? That's the mass number. So 1/12 of the mass number. It means 1/12 of 12. ठीक है, of 12. This 12 cuts out. What remains is 1. So that simply means that 1, the mass of 1, either it can be 1 proton or 1 neutron, but electron does not has a mass of 1 atomic mass unit. Electron has 1 upon 1840 or 0.0005 atomic mass units. So not an electron. That clearly means 1/12 of the mass of a carbon 12 atom means that either the mass of 1 proton or the mass of 1 neutron. Okay, so let's see what it says. Which pair is the sum of their charges equal to 0? Okay, 1 electron and 1 neutron. Not at all. An electron has a charge of negative, neutron has a charge of 0. So a negative 1 and 0 is going to result in a negative 1. So clearly not option A. Let's move on to option B, which says that 1 electron and 1 proton. Okay, 1 neutron and 1 proton, no. Plus 1 and 0 is going to result in plus 1. 2 neutrons, that's going to result in 0. So it has to be option B for the first thing. And second thing, B fulfilled the first condition. The sum of the charge is equal to 0. That's fulfilled because a plus 1 and a negative 1 is going to result in a 0. Okay? The sum of the charges is 0. The second thing, the sum of their mass is almost the same as 1/12 of the mass of a carbon 12 atom. 1 atomic mass unit. The charge of 1 proton is going to be 1 atomic mass unit. And the charge of electron is almost negligible. So we don't consider it. So the mass, the sum of their masses is going to be equal to the same as 1/12 of the carbon 12 atom, because what's 1/12 of the carbon mass of a carbon 12 atom? That's simply 1 atomic mass unit, and a proton has a mass of 1 atomic mass unit. I hope you understood this. Moving on to question number 4, which says an element has two isotopes of relative atomic mass x and x plus 2. Okay, there are two isotopes. Isotopes are atoms of the same element. Okay, the element is the same. You have hydrogen, you have carbon, but what's different is the proton number is the same but different neutron number. So the masses are x and the second mass is x plus 2. Okay? These are the isotopes and this is the mass. Okay? Moving on, the diagram shows the composition of the atoms in the sample of the element. What is the relative atomic mass of the sample of this element? Okay. Now, simple thing, how do you determine the relative atomic mass? You determine the relative atomic mass. What you do is, that's simple. First, you count how many x you have. Okay. If you write the formula, what do you need for relative atomic mass? You need the abundance. Abundance is the availability of that sample in the environment. Okay. You need the abundance or the percentage of that sample. Okay. That's present in the environment naturally. And the second thing you need is their masses. Okay? You need the masses and the abundance. We are not given with the abundance, but we are given with the masses. Let's find out the abundance ourselves by counting them. So how many x we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess that's all we have. And what's the total? 9, 10, 11, 12. So 9 upon 12 equals to 9 upon 12 is the mass of this x. And obviously 3 upon 12 is going to be the mass of x plus 2. So what do you understand by here? By looking at this, if you cut this out, that's going to be 3 upon 4. Take care, 3 upon 4, and this is going to be 1 upon 4. So 3 upon 4 sample is your x, and 1 upon 4 of your sample is x plus 2. Okay, I hope this part is clear. That's your abundance. Okay, that's your abundance. Now let's work out the relative atomic mass. Okay, some people can do it mentally and that's easy for some people, but you got to look at some things. ठीक है, अब जोन सा sample ज़्यादा है ना, the sample that you have more in abundance, the relative atomic mass is going to be towards that sample. ठीक है, अब because this x plus 2 is less in amount. ठीक है, this x plus 2 is less in amount. So firstly, let's eliminate this option. It cannot be x plus 2. ठीक है, and secondly, it cannot be it cannot be x as well. Okay? It has to be something between x and x plus 2. Definitely not towards x plus 2 because x plus 2 is less in amount. Okay? So now we can use the formula or we can do it mentally as well. Mentally, it cannot be in the middle as well. It has to be this. Mentally, it has to be this. It cannot be this. ये तो तब होता है जब दोनों equal होते. देखें दोनों इक्वल होते हैं तो दोनों के सेंटर में आता. देखें x और x plus 2 इनके सेंटर में क्या है? इनके फॉर एग्जांपल ये 20 है और ये 22 है. इन दोनों के सेंटर में क्या है? 21. इसको आप 21 समझ लें. x plus 1 को, it cannot be in the center, तब तो equal होता, और x plus 1.5 तब होता, इसको आप 21.5 समझ लें, जब ज़्यादा आपके पास इसकी abundance होती, तो ये भी possible नहीं है. It's only option A that's possible. Remember one thing, the percentage abundance is always going to be towards that side, उस वाले element के mass की तरफ होएगी, relative atomic mass उस element के mass की तरफ होगा जो जिस element का ज़्यादा abundance है. अब यहाँ पे ज़्यादा abundance x की है क्योंकि it's 3/4, तो mass is going to be towards x, ठीक है, मतलब x की तरफ ज़्यादा mass होएगा. I hope you understand this. और दोनों के सेंटर में, एग्जैक्ट सेंटर में, this is going to be x plus 1, एग्जैक्ट सेंटर में आपका रिलेटिव एटॉमिक मास तब होएगा जब दोनों आपके पास 50-50% अबंडेंस में होंगे. मतलब दोनों की अगर इक्वल अमाउंट होएगी ना, तो रिलेटिव एटॉमिक मास इज गोइंग टू बी एग्जैक्टली एट द सेंटर, ठीक है. दैट्स व्हाट यू नीड टू अंडरस्टैंड. ओके, that was simple. Moving on, question number 5, it says which molecule has only 4 electrons involved in covalent bonds. Okay, we don't have to look at the total number of electrons, but we have to look at is only at the electrons that are involved in the covalent bond. So let's look how many electrons involved in the covalent bond in chlorine. This is Cl, this is Cl, only 2 electrons. How many electrons involved in the covalent bonding in CO2? This is C, this is O, 1 covalent bond, 2 covalent bonds, 1 here, 1 here, 1 2 3 4 5 6 7 8, 8 over here, 2 over here, ठीक है, S, then H and H. I don't know about S, but what I know is about H. H makes a single covalent bond, so 1 over here and 1 over here, so that means 4 of total electrons, ठीक है. Don't worry if you don't know about one thing, you simply should know about hydrogen, ठीक है. You know hydrogen makes a single covalent bond and there are 2 hydrogens, so 1 bond over here it's going to make and 1 bond over here it's going to make, so a total of 4 electrons involved. So I guess that should be option C. And N2, that's going to be a 6 electrons involved, because it's nitrogen with a triple covalent bond, ठीक है. That's what it is, N, triple bond with N. Okay, moving on. The melting points and the boiling points of 4 compounds. W, X, Y, Z are given in the table below. These are the 4 compounds, not elements, not mixtures. We have compounds. The 4 compounds are silicon IV oxide, ethane, bromine, carboxylic acid of formula C16H32O2. A lot of information to digest. Which row identifies W, X, Y, Z? Okay, first we have silicon IV oxide. What do I know about silicon IV oxide? Just let's quickly recall. I know it's a giant covalent structure. I know giant covalent structures are going to have high melting and boiling points, because they have strong covalent bonds holding them together. So what has the highest melting point in all of them? I guess that's definitely Y. It's going to be silicon IV oxide. So Y is my silicon IV oxide. Okay, next thing, what do I have to look at is my ethane. Okay, what can I recall about ethane? I know it's an alkane. I know first 3-4 alkanes are gases. So I know it's going to have a melting point and a boiling point, below room temperature, ठीक है. The boiling point has to be below room temperature because it's above. If it is above room temperature, then it would have been a liquid. So I know it's going to be a gas at room temperature, ठीक है, because first 3-4 alkanes are gases. So the boiling point should be below room temperature. So room temperature is almost my 23. So this is above room temperature. This is below room temperature, a gas at room temperature. So my Z is definitely my ethane. So ethane is going to be Z. Okay, moving on. What do I have next? I have my bromine. What do I know about bromine? And I have studied that bromine is a red-brown liquid. And that means at room temperature, bromine has to be a liquid. Definitely my boiling point has to be above room temperature because it's a liquid at room temperature. So, okay, this is also above room temperature. This is also above room temperature. Both above room temperature. Okay, and now I have to look at one more thing. This melting point. Bromine is a liquid. It cannot have a melting point. It cannot have a melting point above room temperature. Otherwise, it would have been a solid. तो ये तो definitely W नहीं हो सकता. Why? Because look over here. This is your room temperature. Room temperature. ठीक है? If 63 comes above room temperature, ठीक है? 63 comes above room temperature. And if my melting point MP is 63, that means that at room temperature that thing's going to be a solid, because इस point पे आके वो melt हो रही है, ठीक है. If इस point पे आके वो melt हो रही है, मतलब अभी वो solid है, solid. After this 63, it's going to melt, it's going to turn into a liquid. So at room temperature, all this thing is my before 63. Before 63 it's a solid, okay? So bromine at room temperature has to be a liquid, it cannot be a solid. So my X is going to be my bromine, and next is carboxylic acid formula. This why do you think they have given you this formula? This formula is very important. Why it's important? Because look at the number of carbon atoms. Haven't you studied that more the number of carbon atoms, the more the melting point, the more the boiling point, the stronger the bonds, the van der Waals forces? Okay, in O-levels you don't study about the van der Waals forces, but the forces of attraction are greater when you have greater number of carbon atoms. 16 number of carbon atoms. That means a high melting point, a high boiling point, as indicated by W. High melting point, high boiling point. Okay, that's why they've given you, because carboxylic acids, when you think about smaller carbon chains, C1, C2, C3, they're going to be gases or liquids. But when you have longer carbon chains like this, they're definitely going to be solids at room temperature. So your W is going to be a carboxylic acid, which makes it option D to be correct. Moving on. What is the formula of zinc oxide? Okay, that's easy. You should simply know the oxidation number of zinc, which is 2+, of oxygen, which is 2-, and these two cancel out, 2+ and 2-, which makes it ZnO. I hope no confusions in this. Okay, which statement is correct? If the relative formula mass of hydrated sodium carbonate is this, then X is 10. Okay, what you have to think about in this is, first let's calculate the mass of this sodium carbonate, okay? What is going to be the mass of sodium carbonate? The total mass is this, okay? Let's first calculate for this, only this thing, okay? We don't know about how many water X H2O we have. For sodium it's 23 times 2, okay? We have 2 sodium. For carbon it's 12. For oxygen it's 16, so 16 times 3. Let's do it on the calculator, which is going to be 23 times 2 plus 12 plus 16 times CO3, 106, okay? 106 is going to be for this thing. अच्छा, अब ये total आपका mass है इस पूरी चीज़ का, ठीक है? This is the total mass for this entire thing. If you subtract the mass of this thing, you're going to get the mass of water out of it. And what we are interested is in the value of X, because that's going to tell us about how many water we have. So 286 minus 106 going to give us the mass of water. हमने total में से sodium carbonate का mass निकाल दिया, हमारे पास water का mass आ गया. So 286 minus 106 minus 286, that's going to give me 180. 180 is my mass of water, ठीक है? 180 is my mass of water, ठीक है? ये total mass of water है, ठीक है? जितने भी इसमें water हैं, that's the total mass of water. What's going to be the mass, or what's going to be the mass of one water? Let's find it out. Oxygen is 16 and hydrogen is 1. So plus 1 times 2, because we have 2 hydrogen, so that's going to make it 18. Total mass of water जो है 180 है और एक का mass 18 है. So how many water are we going to have? Simple mathematics, you divide, ठीक है? The total mass of water is 180 and the mass of one water is 18. So how many waters do you guys think you're going to have? 180 divided by 18, you're going to get the number of water that are going to be 10. So that means the value of this X is going to be 10. 10, अगर आप 10 water लेंगे, that's how you're going to get 180. And if you add 180 with the mass of sodium carbonate, you're going to get a total mass of this, and that's correct. The X has to be 10, so that makes option A the correct option. Let's read out next options as well, but I know they're going to be incorrect, because when you are sure with your working, you know that you have done it correctly. Okay, phosphoric acid H3PO4 has a relative molecular mass of this. Acha? Okay, let's quickly do it. It cannot be possible, because they can oxygen 4 है. 16 times 4 करें. Do you think you're going to get 50, और उसमें अभी आपने P और H को भी ऐड करना है? Not possible. ठीक है, the relative atomic mass of a sample of an element with isotopes 20 and 22 can only be equal to 21. Not at all possible. ये 21 कब होगा? What have I told you? जब 20 और 22 जो masses हैं वो equal abundance में होंगे, मतलब 50% ही इसका environment में होगा और 50% ही इसका environment में होगा, तो exactly इनके center में 21 आंसर आएगा, ठीक है. बट अगर इनकी abundance different है तो definitely not 21. Okay. The relative atomic mass of an element is the average mass of the atoms of isotopes of that element compared to the mass of a hydrogen atom, compared to the mass of a mass of 1/12 of a carbon 12 atom. Okay, so that's incorrect. Moving on. In a volumetric experiment, okay, 25 cm cube. Okay, what's that? Let's quickly label it. That's the volume of this. What's that? That's the concentration we have of sodium hydroxide reacts exactly with 20 cm cube of dilute sulfuric acid. They can titration is never going to leave you if you are doing chemistry. Either it's ATP, it's 30, or it's MCQs. Titration is always going to be there. Learn the concept. What do we do in titration? ठीक है, what's the concentration of dilute sulfuric acid? That's the easiest titration question you can get. अब आप क्या करेंगे, इन दोनों से that's the volume, that's the concentration. इन दोनों से आप sodium hydroxide के moles निकालेंगे. Remember, a simple roadmap, a framework of a titration question. सबसे पहले एक के moles निकलवाएंगे. They're gonna get the moles of one. ठीक है, उससे equation को use करके आप दूसरे के moles निकालेंगे. And when you are done with the moles of the second thing, then what do they ask for? They are gonna ask for the concentration of that second thing by using the volume of the second thing. ठीक है, अब ये थोड़ा confusing लग रहा है. Let's try it. ठीक है, सबसे पहले moles निकालते हैं NaOH के. That's gonna be 25. That's going to be the volume times concentration. Concentration is 0.100. क्योंकि you know we always get it in dm cube, ये cm cube में है, तो हम इसे divide करेंगे 1000 से. So quickly do it. Let's quickly do it. 25 times 0.100. The answer is going to be divided by 1000, and that's give you 0.0025. 0.0025 moles. ये किसके moles हैं? These are the moles of your NaOH. अब problem क्या है question में? इसके 2 moles के साथ इसका 1 mole react करता है. Quickly make a ratio. NaOH ratio H2SO4. Simple ratio है कि इसके 2 moles के साथ इसका 1 mole react करता है. अब NaOH के इसमें कितने moles हैं? 0.0025. उसके साथ इसके कितने moles react करेंगे? X moles. Find out the value of X. It's gonna be divided by 2. 0.00125 is the value of X. 0.00125 moles is the value of how many moles of H2SO4 we have. Now what do we have to find? What's the price in this question? The concentration of dilute sulfuric acid. How are we going to get it? We have the moles of sulfuric acid. That's simple. Moles divided by the volume. Going to get the concentration. 0.00125 divided by the volume, which is 20 cm cube. We cannot take the volume in cm cube. We have to take it in dm cube. So 20 1 2 3 0.020 dm cube. So 0.00125 divided by 0.020 0.0625. That's going to be option A. I hope you got how we got it. These were the moles. This was the volume. Moles divided by volume equals to concentration, and that came out to be 0.0625. Moving on to the next question. The equation for the reaction between ammonium chloride and calcium hydroxide is shown. Okay, equations are very useful. What's the most important thing that you look at in an equation is this. This is the key in every equation. And what's this? This is the coefficient. This tells you that 2 moles of ammonium chloride gonna react with 1 mole of calcium hydroxide, gonna produce 2 moles of ammonia, 1 mole of calcium chloride, and 2 moles of your water. Okay, that's the key in an equation, and I believe that's the one thing that most people tend to struggle with. They don't look at the coefficients. Okay, now let's read. 10.7 grams of ammonium chloride and 14.8 grams of calcium hydroxide are mixed and warmed. Okay, you have this, they're mixed and warmed. I am sure they're going to ask about something according to the masses. Okay, 10.0 gram of calcium chloride is obtained from the reaction. What is the percentage yield of calcium chloride? Always remember, in percentage yield questions, what's the roadmap? The roadmap is that what the question is going to give you is going to be what actually happened in the laboratory. Okay, that's what actually happened in the lab. When you performed the experiment in the lab, you got 10 grams of calcium chloride, but that's not the reality. when you're going to calculate it, अब ये concept people struggle with. They don't get what's the actual yield, what's the theoretical yield. They mess up with the formulas. You got to remember one thing. This is what you got in laboratory. When I performed the experiment in the laboratory, I weighed my calcium chloride and I got 10.10 grams. But when I performed the calculations on the paper, my answer was different. Okay? That's going to be the theoretical yield. Theory means what you do on paper. So now this is my paper and I'm going to do it over here and let's see how much yield I get of calcium chloride. Okay? So let me take any kind of mass. Let me take this. Okay? Are we given with what's in excess? Because we never take the one with excess. The equation for the reaction between ammonium chloride and calcium hydroxide. Okay? इतना ammonium chloride है, इतना calcium hydroxide है. अच्छा, okay. ठीक है, और इतना ये बना है. व्हाट इज़ द परसेंटेज यील्ड? वी डोंट नो व्हाट्स इन एक्सेस. ठीक है, इन दोनों में से कौन सा रिएक्टेंट एक्सेस में है? वी डोंट नो. सो लेट्स जस्ट टेक फॉर अमोनियम क्लोराइड. ठीक है, अमोनियम क्लोराइड से ही हम देख लेते हैं. सो लेट्स फाइंड आउट द मोल्स ऑफ अमोनियम क्लोराइड. सिंपली आप इसको मोल्स के भी मेथड से कर सकते हैं, इसको मैथ्स के भी मेथड से कर सकते हैं. ठीक है, मोल्स के मेथड से थोड़ा लंबा है तो हम मैथ्स के मेथड से कर लेते हैं. ठीक है, बट मैथ्स के मेथड से भी आप फिर क्या करते हैं कि आप इस 2 को भूल जाते हैं. मेनी पीपल टेंड टू फॉरगेट दिस 2, दे मेस अप. सो लेट्स डू इट विद द मोल्स मेथड. अच्छा, अब मोल्स मेथड क्या है कि 10.7 ग्राम में कितने मोल्स होंगे अमोनियम क्लोराइड के. सो लेट्स फिगर इट आउट. सबसे पहले मोल्स इक्वल टू मास अपॉन एम आर. मास है 10.7, एम आर होगा सबसे पहले हमें लेना है नाइट्रोजन का, दैट्स गोना बी 14. फिर हमारे पास 4 हाइड्रोजन्स हैं विच इज़ गोना बी ओनली 4, 1 times 4. देन वी हैव क्लोरीन विच इज़ 35.5. सो लेट्स ऐड दिस. We have to add it, not multiply. Add it. So 14 plus 4 plus 35.5, that's going to give me 53.5. 53.5. So 10.7 divided by 53.5, 10.7 divided by 53.5, I get 0.2 moles. ठीक है, so my moles are coming out to be 0.2. okay, now I have the moles of my ammonium chloride. ठीक है, 0.2. अब फिर से what did I tell you guys? I told you the most important thing is these coefficients. ठीक है, ये जो साथ लिखा होता है बहुत इंपॉर्टेंट है. इसके 2 मोल से कैल्शियम क्लोराइड का 1 मोल बनता है. ठीक है, इसके 2 मोल से इसका 1 मोल बनता है. तो इसके 0.2 मोल से इसके कितने मोल्स बनेंगे? सिंपल मैथमेटिक्स. इसके 2 मोल से इसका 1 बन रहा है तो इसके 0.2 से इसका 0.1 नहीं बनना चाहिए. अच्छा, अगर इस तरह नहीं समझ आ रहा तो आप सिंपल दैट्स गोना बी कि आप वो बना लें, सिंपल वो बना लें, रेशो बना लें, अमोनियम क्लोराइड रेशो कैल्शियम क्लोराइड. ठीक है, एंड दैट्स गोना बी इसके 2 मोल से इसका 1 मोल बनता है तो इसके 0.2 मोल से इसके x मोल्स बनेंगे और x की वैल्यू आ जाएगी 0.1. ठीक है, अब रिमेंबर हमारे पास इसके कितने मोल्स हैं? 0.1 मोल्स. ठीक है, दैट्स व्हाट यू हैव टू रिमेंबर. अब इसके 0.1 मोल्स में इसका कितना मास होना चाहिए? ठीक है, 0.1 मोल्स में कितना मास होना चाहिए? लेट्स फिगर इट आउट क्विकली. ठीक है, मास इक्वल्स टू मोल्स टाइम्स योर एम आर. ठीक है, मोल्स टाइम्स योर एम आर. आई होप यू एग्री. 0.1 हमारे मोल्स हैं टाइम्स माई एम आर. एम आर कितना होगा? कैल्शियम इज़ 40 एंड क्लोरीन इज़ 35.5 और यहाँ पे 2 क्लोरीन्स हैं तो टाइम्स 2, दैट्स गोना मेक इट 71. सो 40 प्लस 71 टाइम्स 0.1, लेट्स डू इट. 40 प्लस 71 टाइम्स 0.1, 11.1 grams. मेरा mass आना चाहिए था 11.1 grams. This should have been the mass, and that's the mass in theory. The mass I calculated it to be. But what's the mass in reality? That's 10.0 grams, and that's unfair because according to my theory, मेरा इतना mass आना चाहिए था कैल्शियम क्लोराइड का, but आया कितना? इतना. लेबॉर्ट्री में इतना आया, थेरी में इतना आया. सो लेबॉर्ट्री में जो आया उसको ऊपर रखें 10.0, जो थेरी में आया उसको नीचे रखें 11.1 times 100%. That's going to give you the percentage yield. If you want the formula, that's simple कि ऊपर आती है आपकी actual yield, नीचे आती है आपकी theoretical yield times 100. ठीक है, so that's the formula. 10.0 divided by 11.1 into 100. 10.0 divided by 11.1 times your 100. That's going to give me a 90% yield, and if you round it off, this 9 upon here, that's going to be rounded off to 1, so that's 90.1%. Okay, and that makes it to be option D. Okay, moving on to the next question, which says the diagram shows a simple electrolytic cell. Okay, we have a simple cell and you are given with some numbers 3, 1, 2, okay, these are the electrodes, these are the electrolyte. Which arrow shows the movement of electrons? Okay, that's quite interesting. You should know that you're given with a lot of options as well. आपके electrolyte में, what do you guys think? In your electrolyte, this is your electrolyte, what kind of things move? Do you think your electrons are moving in your electrolyte? Never. Electrons are never moving in the electrolyte, but the thing that's moving in electrolyte is ions, not your electrons. An electrolyte can conduct electricity because of the movement of the ions. ठीक है? अगर आप NaCl का electrolysis करें, so what's basically happening is your sodium and your chloride ions are moving in this electrolyte. ठीक है? So electrons never move in your electrolyte. So जिसमें भी option 2 है उसको cross कर दें. 2 cross and 2 cross. Which arrow shows the movement of electrons? ठीक है. अब movement of electrons आपके पास बच गया है. इसमें भी option 2 है, so ये भी निकल जाएगा. तो by the method of elimination, it's C. And that's simple. How do your conventional current moves? What's the movement of conventional current? From positive to negative moves your current. And electrons flow opposite to the movement of current. ठीक है? They flow from negative to positive. Remember. And what's happening over here? It's moving from negative towards positive. Just think about it. Electrons are being pushed out or repelled by the negative terminal of the battery and are attracted by the positive terminal. So they move from the negative towards the positive. And the arrows well indicate the direction of electrons. Moving on to the next MCQ, which says that which changes are observed during the electrolysis of aqueous copper 2 sulfate using copper electrodes. ठीक है? Now examiner only uses one word that is enough to confuse the children. That's using copper electrodes. ठीक है? He does not tell you that entire scenario of the electrolysis is going to change by the single word that you're using copper electrodes. You know copper electrodes are reactive electrodes. So what's going to happen at the anode? Oxidation is going to happen, but of what? Not of the mixture or the solution you've taken, not of copper 2 sulfate. Oxidation is going to happen of your anode. ठीक है? So anode is going to oxidize. Oxidize means loss of electrons. Your copper is going to lose 2 electrons. It's going to form copper 2 plus ions plus 2 electrons, and your anode's going to dissolve. ठीक है? That's what's going to happen at the anode. And what's going to happen at the cathode? Red cat. So reduction is going to happen. Reduction is going to happen at the cathode. What's going to reduce? It's not going to be the solution. Nothing from the solution. What you're doing is the anode's going to first dissolve in the solution, then from the solution that anode which is dissolved is going to reduce at the cathode, and your copper 2 plus ions are going to gain 2 electrons. Reduction is the gain of electrons to form copper. So what's basically happening, a pink solid is deposited at the negative electrode. What's the negative electrode? It's going to be the cathode. So yes, your copper is going to reduce and deposit at the cathode, making option 1 correct. What's 2? Bubbles form on the positive electrode. What's the positive electrode? It's the anode. Okay? Your positive is your anode, your negative is your cathode. And why bubbles? Using copper electrodes. If any one of you was confused right now, okay, hasn't read the question properly, that you're using copper electrodes, must have confused thinking it's aqueous copper 2 sulfate, and what's going to discharge is going to be OH negative ions from water. No, the entire scenario of the electrolysis has been changed, and now what's basically happening is copper is being reduced, copper is being oxidized. Okay, so option 2 is incorrect, and it was I guess a distracted option for those people who haven't read this word. Okay, moving on to option 3, which says the color of the solution does not change. That's going to be extremely correct. Why? Because the blue color of the solution is because of the copper, and your copper is not being is not being getting out of the solution. Why? Because the amount of copper that gets out gets in from the anode. It gets deposited on the cathode. The same amount of copper gets into the solution from your anode. So the color of the solution is going to remain constant. That makes option 1 and 3 correct, and it's going to be C. Okay, moving on. Which row describes a hydrogen-oxygen fuel cell? Okay. Chemical product, hydrogen and oxygen, water. So what's the equation for a hydrogen-oxygen fuel cell? You take hydrogen, you take your oxygen, and what you form is H2O. And if you balance this equation, you're going to put a 2 over here and a 2 over here. So the only chemical product of a hydrogen-oxygen fuel cell is water. Okay? Making option A and B incorrect. Okay, now let's read the comparison of a fuel cell with a petrol engine. Okay, a petrol engine releases carbon dioxide, whereas a hydrogen oxygen fuel cell is extremely clean, making water the only chemical product. Hydrogen has a lower energy content by mass than petrol. That's extremely incorrect. Why? Do you know why? Because a small amount, the equal amount, this is your hydrogen, and this is your petrol. Okay, this is equal amount of petrol. I say C8, not C8, it's going to be C6H. If you're using hexane, it's going to be C6H12 13 14. Okay, so equal amount of your petrol, equal amount of your hydrogen. What's going to happen is hydrogen oxygen fuel cell is more efficient, which means it releases more energy for the same amount of mass. It's going to be extremely efficient. So that's incorrect. A renewable fuel may be used in a fuel cell. A petrol engine uses a non-renewable fuel. That's correct, because hydrogen is renewable. Okay, hydrogen oxygen fuel cell is renewable. May be used in a fuel cell, whereas a petrol engine is non-renewable. So that's correct, and I guess it's going to be option D. Moving on to question number 14, which says that which statements about endothermic reactions are correct? Okay, so we are dealing with endothermic reaction. That means that what we're doing is we are absorbing energy from the surroundings. Energy is absorbed from the surroundings. That's correct, because energy is getting into the system. Energy is released. That's incorrect. That's going to be for exothermic. The temperature of the reaction mixture falls. That's correct, because from the reaction mixture you are basically absorbing the energy. For example, this is your salt which you have dissolved, and the reaction is endothermic. So what's going to happen is, this is your thermometer. The temperature on your thermometer is going to decrease because energy is absorbed into the salt. So what's going to happen, for example, initially if it was 25 degrees Celsius, it's going to turn to 18 degrees Celsius. The temperature of the reaction mixture falls because energy is getting into this thing. So the energy of this water is gonna, or the temperature is gonna decrease. The temperature of the reaction mixture rises. That's gonna be incorrect, making option 1 and 3 correct. So that's gonna be option A. Okay, this is gonna be about bond breaking and bond making. Hydrogen and chlorine react to form hydrogen chloride. That's the bond energies. It's energy data is given in the table. What is the enthalpy change for this reaction? Okay, now what do you have to do? The first thing I always suggest in this question is to draw the thing. H2 means one hydrogen bond. And this Cl2 means that one Cl bond. Cl single bond. And this 2 HCl means, if you haven't drawn this thing, you would never know that over here it's 2. That means one HCl bond and then another HCl bond. So that's what the reaction looks like. So over here, first you have the energy. This is the energy. That's basically the bond breaking is endothermic. So that's the energy that's going into the system to break the bonds, and bond making is exothermic. That's the energy that's coming out of the system because as bonds are being formed. So for your reactants, that's bond breaking. So let's figure out the energy for bond breaking. You have one HH bond, which is going to be 436. That's going to be 436, plus you have one Cl bond, which is going to be 242, and you form your 2 HCl bonds, which is going to be 2 times 1 HCl bond is 431. So it's going to be 431. And let's figure it out for bond breaking. How many energy we're consuming? 436 plus 242. 436 plus 242, and that's going to give me 678. So 678 is the energy that basically is going into the system, and the energy that's coming out is gets subtracted. So 2 times 431. 2 times 431, that's going to make it 862. 862. So that's going to be the total enthalpy change for the reaction, the answer to this thing. So 678 minus 862. 678 minus 862. And that's going to give me negative 184, equals to negative 184 kilojoule per mole. So I guess this option B is going to be my answer. I hope you got this thing. The most important key step was writing this in this form so that you know what you have to do. And the other important key concept or the key takeaway was that the energy that's going into the system and the energy that's coming out of the system. You just have to subtract the both energies that's going in and that's coming out. Okay, moving on. Question number 17. 2 reactions each produce a gaseous product. You have 2 reactions, each is producing a gaseous product. Why do we care about the gaseous product? Because that means that if you have to read the question properly, if you apply pressure is going to have effect to the if it's a reversible reaction. Because for gases, pressure affects the rate of the reaction. The reaction are performed separately using the same conditions of temperature and pressure. You have similar temperature and pressure conditions. The volume of the gas formed in each experiment is measured over time, and the results are plotted in the graph shown. At which point is the rate of the production of the gas greatest? What do you guys think? At which point is the production greatest? I guess it's going to be A. Look at the gradient. The gradient of the graph tells you the production rate. What do you guys think? Is this gradient steep or this gradient steep? I'm just drawing all the gradients. What do you guys think? Which of the line among these three are steepest? Is the steepest? Obviously A. Look at the steepness of this line and this line. Obviously it's more steeper. Steeper means, for example, if you have a hill slope like this and a hill slope like this, which is more steep? Obviously this one, because it has a greater gradient. So that's what you have to understand. And the volume of the gas collected is going to be the greatest over here. The first, because as the reaction proceeds, you have, I guess, more amount of your reactants, and they react more vigorously at the beginning, and as the time proceeds, the amount of the reactants decreases, hence the rate decreases. Okay. Question number 18, which says the reaction between calcium oxide and carbon dioxide is irreversible and the forward reaction is exothermic. Okay, the reaction is reversible, not irreversible, and the forward reaction is exothermic. Okay, whenever they tell you the forward reaction is exothermic, you just do this, you write exo, and you automatically know the backward reaction is going to be endo. Okay, the mixture of calcium oxide and carbon dioxide is placed in a heated flask and the reaction reaches an equilibrium. Which statement about the equilibrium is correct? Okay. Let's see towards option A, which says less calcium carbonate is going to be produced if the pressure of the flask increases. Okay, for pressure, you have to look at the moles of the gases. This is solid, so you don't look at this moles. Why? Because it's a solid, you only look at the moles of the gases. So one gaseous mole on the reactant side, one gaseous mole on the product side. So equal moles, hence no effect of pressure. Equal moles means no effect of pressure. More calcium carbonate is produced when the temperature is increased. No. When the temperature is increased, it's going to move backward. When you increase temperature, the equilibrium moves towards the endo side. It's going to move backward. Less calcium carbonate is going to be formed, hence making option B also incorrect. The flask must be sealed if the equilibrium is to reach. That's correct. Whenever you are doing a reaction which involves equilibrium, you always need to have a closed system. A closed system means nothing enters or leaves the system. Okay? Oh, I forgot one thing. That's a solid over here. Sorry. That's a solid. Oh, I forgot one thing. So there's going to be 1 mole of gas over here and 0 moles of gases over here. Sorry, I thought it was a gas. I'm so sorry. So let's read option A again. Less calcium carbonate is produced if the pressure of the flask increases. Okay, so if the pressure increases, that's going to move the equilibrium towards the side that has less moles. Okay, less calcium carbonate is going to be produced, so equilibrium move towards this side because this has 0 moles and this has 1 mole. So more calcium carbonate is going to be produced. This is still incorrect, okay? But you have to consider that over here you have 0 moles because that's a solid. Sorry. Okay, option D, this one is correct. Option D, when equilibrium is reached, the reaction stops. That's completely incorrect. The reaction keeps on continuing, but what happens is the rate of the forward and the backward reaction equal. Hence, you feel as if no reaction occurs because the concentration and the amount of your reactants and products remains unchanged, but the reaction is continuously still happening. Okay? Let's read this 19. In the Haber process, hydrogen and nitrogen react to form ammonia in the presence of a catalyst. You know it's going to be iron catalyst. Which reactant is obtained by the fractional distillation? That's surely going to be nitrogen. You get nitrogen by the fractional distillation of which substance? Of liquid air. And which catalyst is used? That's going to be the easiest one. The catalyst is going to be iron, and the substance by fractional distillation is going to be nitrogen. And how do you obtain hydrogen? What do you guys think? You're going to obtain hydrogen by the methane. Yeah, you get hydrogen by methane. I guess that's clearly stated in the syllabus. Go read the syllabus. It's written that you get hydrogen from methane and nitrogen from fractional distillation of liquid air. Okay, 20. Chlorine reacts with aqueous sodium bromide. Okay, you have chlorine, you're going to react it with sodium bromide. What's going to happen? Chlorine is more reactive than bromine. So what's going to happen? It's going to form sodium chloride, and bromine is going to come out to form an aqueous solution of sodium chloride and bromine to get a simple displacement reaction. Which statement about the reaction is correct? Okay, we got to write the equations for this. So at first you have, I'm going to write an ionic equation. So you have bromide ions, and what happens is, and you have chlorine. That's an ionic equation. So sodium is going to be spectator ions at both sides, so it gets cancelled. That's why I'm not writing sodium over here. And you're going to form chloride ions, and you're going to form Br2. So there's going to be a 2 over here. Okay, bromide ions are oxidized because they lose electrons. Okay, they are oxidized because they lose electrons. Okay, you're coming from a -1 to 0. That's clearly oxidation, and that's loss of electrons, which makes option A correct. Let's read other options as well. Chlorine atoms are oxidized because they gain electrons. Oxidation is not gain. Oxidation is loss of electrons, making it incorrect. Sodium ions oxidize. Sodium, nothing happens to sodium ions. ठीक है, they remain the same. Their oxidation state not changes. यहाँ पे भी वो Na bromine के साथ +1 पे भी हैं और यहाँ पे chlorine के साथ भी +1 पे ही हैं. Okay. The reaction does not involve oxidation or reduction. That's completely incorrect. It's a complete redox reaction. What's happening is your bromide ions are getting oxidized because they're losing electrons, and chlorine gas is getting reduced to form chloride ions because it's gaining electrons. Okay, that's what's happening. 1 mole of compound X gives 2 moles of ions in aqueous solution. X reacts with ammonium carbonate to give an acidic gas. What is compound X? Okay. So you have 1 mole of compound X that gives 2 moles of ions in aqueous solution. ठीक है, 2 moles of ions in aqueous solution. Calcium hydroxide, CaOH2. ठीक है, ethanoic acid, which is going to be CH3COOH. Nitric acid, HNO3. Sodium hydroxide, NaOH. ठीक है, अब सबसे पहले when aqueous solution is going to form, calcium hydroxide is going to give how many moles? 3 moles of ions. Why? 1 mole of calcium ions and 2 moles of हाइड्रोक्साइड आयंस. ठीक है, यू गॉट टू अंडरस्टैंड कि एक्वस सोल्यूशन में इसके 2 मोल्स आएंगे और इसका 1 मोल आएगा. दैट्स मेक्स ऑप्शन ए इनकरेक्ट. इसके 1 मोल आएगा इस एथेनोएट का और 1 मोल आएगा हाइड्रोजन का, तो 2 मोल्स. 1 मोल एच का और 1 मोल नाइट्रेट का, तो 2 मोल्स. 1 मोल सोडियम का, 1 मोल हाइड्रोक्साइड का, तो 2 मोल्स. ठीक है, सो ऑप्शन बी सी डी एनी वन कैन बी करेक्ट. X reacts with ammonium carbonate. ठीक है, whatever X is, it reacts with the carbonate to give an acidic gas. And I guess when acids react with carbonates, they give carbon dioxide, which is an acidic gas. What acid do we have among these? Ethanoic acid, nitric acid, and sodium hydroxide. Okay, now we have 2 acids, ethanoic acid and nitric acid. Let's figure out among them. We have to read the question again and again. ठीक है, 1 mole of compound X gives 2 moles of ions in aqueous solution. Okay, ये तो हो गया. X reacts with ammonium carbonate to give an acidic gas. It can be both ethanoic and nitric, but we got to still figure out what's correct. 1 mole of compound X gives 2 moles of ions in aqueous solution. ठीक है, दोनों 2 moles ही देते हैं. X reacts with ammonium carbonate to give an acidic gas. Acidic gas carbon dioxide होगी. What is compound X? Ethanoic acid होगा, nitric acid होगा. 1 mole है compound X का, gives 2 moles of ions. Both 1 mole gives 2 moles. What's going to be correct? Let's read it again. X reacts with ammonium carbonate to give an acidic gas. X going to react with ammonium carbonate. Considering ethanoic acid is a weak acid, let's go with option C. I guess that's going to be correct because we consider ethanoic acid to be a weak acid, and here we go with the correct answer, which is going to be option C. Okay, moving on to question number 22, which says which statement about weak acids is correct? Some molecules do not dissociate. ठीक है, weak acids do not react with carbonates. That's incorrect. They react, but they react slowly. So that's incorrect. Weak acids always form more dilute solutions than strong acids. Always form more dilute solutions. No, that's incorrect, because if you take less water, you're going to form a concentrated solution. Weak acids always have a lower pH values, they have a higher pH values. देखिए, अगर ethanoic acid है तो उसकी शायद 5 हो, but अगर HCl है तो उसकी शायद 2 हो, तो they have a higher pH values. Weak acid. So incorrect. Weak acids do not react. Incorrect. Some molecules do not dissociate. That's correct, because there's a partial dissociation, not a full dissociation. Okay, which compound is the least soluble in water? Okay, calcium chloride. Chlorides are soluble except for lead and silver. Lead nitrate, all nitrate soluble. Magnesium carbonate insoluble. Carbonates are insoluble apart from your group 1 and ammonium. And potassium sulfate, all potassium salts are soluble. So least soluble is going to be option number C. Moving on to 24, which statement about water crystallization is correct? The ratio of COCl2 ratio H2O in a hydrated cobalt 2 chloride is 6:1. That's just flipped. It's 1:6. ये 1 होता है, ये 6 होता है, तो सिर्फ आपको कंफ्यूज करने के लिए 6:1 लिखा है. That's 1:6. The ratio of CuSO4 that's 5H2O in a hydrated is 1:5. That's correct. 1 of copper sulfate and 5 of H2O, which makes it option B correct. Moving on to 25, the diagram shows the section of the periodic table which element is a metal that has exactly 3 outer shell electrons? It's 3 outer shell electron means period number 3. This is the first period, this is the second period, this is the third period. In third period we have C, so it's going to be option C, because the number of outer shell electrons equal to the period number of that element. 26. The table compares two properties of lithium and potassium, which was correct. Okay, down the group you should know the density is going to increase, okay, and greater tendency to form a positive ion. Down the group, the tendency to form a positive ions will also increase. So lithium is above, potassium is below. So potassium is going to have a greater density and it's going to have a greater capacity to lose the ions. So greater density is going to be of potassium and greater tendency is also going to be of potassium, making it option D. You just had to learn the trends for group 1, okay? Which properties are correct for the element copper melting point? Obviously not this, because it's a transition element. It's going to have a high melting and boiling point. Malleability is going to be extremely high, because that's why you use copper in your wiring. Okay, your electrical wiring consists of copper because of its high malleability and ductility, and moreover it's a transition element. So these are the characteristic properties. Wiring is about ductility and turning into sheets or layers is about malleability. Okay. Which statement is correct? Copper is unreactive because of its oxide layer. That's incorrect, because it's below hydrogen. It's low in the reactivity series. That's why oxide layer is for aluminum. Okay, gold and silver are used to make jewelry because they corrode very slowly. Okay, we can think about this. Let's move on. Magnesium can be displaced from an aqueous solution of its ions by adding aluminum. That's incorrect. Magnesium is more reactive. Aluminum cannot displace magnesium because magnesium is above in the reactivity series. Zinc gains electrons more readily than magnesium gains electrons. That's zinc gains electrons more readily than magnesium gains electrons. Okay, it's not about losing electrons, it's about gaining electrons. So you have magnesium, you have zinc, because they corrode very slowly. So you have magnesium, you have zinc. Magnesium is above, so it has a greater tendency to lose electrons, and zinc gains electrons more readily than magnesium gains electrons. Zinc is below magnesium, so yeah, it's going to lose electrons less readily. Magnesium is going to lose electron and it's going to gain electrons more readily. For example, if you electrolysis kare, this one's correct. Zinc gains electrons more readily than magnesium gains electrons. Whereas gold and silver are used to make jewelry because they corrode very slowly. That also seems correct, but I guess that's more factually correct. Magnesium gains electrons more readily. Zinc gains electron more readily because zinc is lower in the reactivity series. It's less of a metal. It's less electropositive than magnesium. Magnesium is more electropositive. It has a greater tendency to gain ions, and therefore to lose ions. To lose ions. Therefore, it's going to gain less slowly. Okay, so that's what you have to understand over here. This one also seems correct because they corrode very slowly, but I guess that's one's more factually correct. What you can be exactly sure about. Okay. Which reaction takes place in a blast furnace? Okay, definitely not this. Definitely not this. This one, yeah. Definitely not this. If you've learned the reaction, you know this one's a simple acid-base reaction. This one, silicon oxide, the sand or the impurities in the iron 3 oxide reacts with calcium oxide to form calcium silicate, which is also known as slag. Okay. 31. The presence of water can be confirmed by the use of either anhydrous cobalt 2 chloride or anhydrous copper 2 sulfate. Which observations are correct when water is present? Okay, what happens for cobalt 2 chloride is it turns from blue to pink, and what happens to this thing? It turns from white to blue. Okay, anhydrous cobalt 2 chloride turns from blue to white. That's incorrect. Cobalt chloride turns from pink to blue. That's incorrect. It turns from blue to pink. Copper sulfate turns from blue to pink. That's incorrect. It turns from white to blue. Okay. Ammonium phosphate can be used as a fertilizer. What is the percentage by mass of the elements that improve the plant growth in ammonium phosphate? Okay, what kind of elements are we looking for? NPK. Fertilizers: nitrogen, potassium, and nitrogen, phosphorus, and potassium. Okay, nitrogen, phosphorus, and potassium, what we're looking for. So over here we have this nitrogen and we have this phosphorus. So what do we have to do? The percentage by mass of the elements, it's going to be, we have to take the mass of nitrogen and phosphorus above and all this mass below. So the mass for nitrogen is going to be 14, but how many nitrogens do we have? We have 3 nitrogens, ठीक है. So 14 times 3 plus phosphorus, we have 1. I guess phosphorus, it's let's check out. I guess it's 31 in the periodic table. Let's check out 31. Okay, so it's going to be 31 plus 31 upon the total mass. The total mass is going to be, first for nitrogen, it's going to be 14 times 3. Then for hydrogen, it's going to be 4 3 times 12, so plus 12. And plus phosphorus, it's going to be 31 plus oxygen 4 times, 16 times 4. So first let's get the above mass, which is going to be 14 times 3. 14 times 3 plus 31, 73. 73 ऊपर वाला मास होएगा. ये उन एलिमेंट्स का है जिन्होंने इम्प्रूव किया प्लांट ग्रोथ, ठीक है, नाइट्रोजन और फॉस्फोरस. अब पूरे का मास कितना है? 14 टाइम्स 3 टाइम्स 12 प्लस 31 टाइम्स प्लस 16 टाइम्स 4. सो आई होप आई रिमेंबर. हम सिंपल कर देते हैं. 73 प्लस हमारा हाइड्रोजन जो 12 आ रहा था, और प्लस हमारा ऑक्सीजन जो कि था 16 टाइम्स 4, which makes it 149. So upon 149 times 100, which is going to give us 73 divided by 149 times 100, which is going to give me 48.9%. 48.9 equals to 49% if we round it off, which makes it option D to be correct. ठीक है, I hope you got it. You just had to look for those elements that improve plant growth. And PK fertilizers use, you want nitrogen in your fertilizer, you need phosphorus and potassium. So nitrogen and phosphorus mass you had to take above, the total mass of this thing below, and times 100. Okay, which statement is correct? An unsaturated hydrocarbon is one in which more solute can dissolve. Oh my god, they're trying to confuse you, the saturation with solubility. That's incorrect. An unsaturated hydrocarbon is the one that has a carbon-carbon double bond. ठीक है? That's what you mean by unsaturation. This is just I guess a distracted option. Okay, members of a homologous series each differ from the next by 1 methyl unit. That's extremely correct. Option B is going to be correct. That's the... Okay, so structural isomers have the same displayed formula and different structural formula. That's incorrect. They're the same, not the displayed formula. They have the same molecular formula and different structural formula. So incorrect. The general formula of carboxylic acid CnH2n plus 1. यहाँ पे plus 1 आना चाहिए था. CnH2n plus 1 COOH. So that's incorrect. ठीक है. What is the name of the ester? This let's break it down from here. I guess we should break it down. ये वाला side हमारा होएगा acid part, and this one's gonna be our alcohol part. ठीक है. Let's just draw it. C3. It's gonna be more easy for us. 1 2 3, and it's gonna be a double bond. फिर O, फिर C2, and it's gonna be H5. 1 2 3 4 5. 1 2 3 4 5. C3 है और H7 है. C3H7. 1 2 3 4 5 6 7, और यहाँ पे डबल बॉन्ड आएगा. अब सही है. 1 2 3 4. 1 2 3. That's more bonds. यहाँ पे C3 को पूरा किया तो 1 2 1 2 3. Why isn't it coming H5? C3 H7. ठीक है. 1 2 3 H 1 2 3 4 5. Okay, यहाँ पे एक और C है. That's why I guess ये सही नहीं आ रहा था. Sorry. Then there's a C. Then there's a double bond. Then there's an O. Then there's again a C. एक सेकेंड. Then there's again a C. ठीक है. और फिर यहाँ पे एक और C है, और फिर यहाँ पे इस तरह 1 2 3 4 and 5. ठीक है. अब ये सही हो गया. सॉरी I'm so sorry. अच्छा, अब ये वाला पार्ट हमारा आ गया. 1, how many carbons do we have in total? 1 2 3 4. ये वाला पार्ट आ गया. ब्यूटेनोइक एसिड आ गया. और ये वाला पार्ट जिसमें हमारे पास 1 2 3 4 5 हाइड्रोजन हैं और 2 कार्बन से आ गया हमारा एथेनॉल. सो जब हम एथेनॉल और ब्यूटेनोइक एसिड को कंबाइन करेंगे, सो व्हाट आर वी गोना फॉर्म इथाइल ब्यूटेनोएट. ठीक है. सो दैट्स गोना बी इथाइल ब्यूटेनोएट. ठीक है. Petroleum is separated into useful fractions by fractional distillation. Which of these fractions has the lowest boiling point? Okay, you should know that as we go up, ठीक है, the smaller chain, they have lower boiling points. ठीक है, यहाँ पे ethane है और यहाँ पे आपके पास decane है. So ethane is going to have a lower boiling point. Why? Because you're going up. So bitumen, no, just if you've learned it, you should know bitumen is at the last. Fuel oil is also a big one. Kerosene, paraffin, or यहाँ पे gasoline. So gasoline is above paraffin, so it's going to have lower melting point. ठीक है, and a boiling point. ठीक है, that's the trend. You got to know that as you go up, your viscosity, it decreases, your melting boiling points, they also decrease, and your chain length also decrease, and your flammability increases. Okay, the only thing that increases is going to be your flammability. Flammability is the property of that hydrocarbon to burn itself. Okay, how readily it's ready to burn. Okay, so we're done with this. Moving on to 35, which says that which equation represents a substitution reaction. Okay, so C3H8, that's an alkane. Okay, we are adding chlorine into an alkane and we're forming C3H7 plus HCl. I guess option A is correct. What's wrong with option A? It's extremely correct. Moving on to next one. Not a substitution, not a substitution, not a substitution. Okay, moving on. Which shows the minimum number of the moles of oxygen needed for the complete combustion of 1 mole of the named alcohol. We need the minimum moles of the oxygen. Okay, minimum moles of oxygen needed for the complete combustion. We cannot do an incomplete combustion. We have to make sure that carbon dioxide is formed, not carbon monoxide. 1 mole of the named alcohol. Let's do it for. Okay, one thing you guys should know that for butane 1-ol, butane 2-ol, the moles of oxygen cannot change because they're structural isomers. The molecular formula for butane 1-ol and butane 2-ol is exactly the same. Okay, and for propane 1-ol and propane 2-ol, the structural formula is different, but the molecular formula is same. So the moles are not going to change. So let's do for first butanol and then make a combustion equation for propanol. For butanol, it's going to be C4H9OH plus O2 forming CO2 plus H2O. So we have 4 carbons. Let's put a 4 over here. How many hydrogens we have? Don't forget this one. We have 10 hydrogens. Let's put a 5 over here. How many oxygens we have? 4 2 times 8 plus 5. 8 plus 5 makes it 13. So it's going to be we cannot write it 13. So it's going to be a 13 upon 2. We multiply the entire equation by 2 to finish this 2 in the denominator. That's going to make it a 2 over here, a 13 over here, and a 8 over here, and a 10 over here. So definitely not A and B. Moving on to propane 1-ol. So that's going to be C3H double it first 6 and 7 OH plus O2 forming CO2 plus H2O. There's going to be a 3 over here, and 7 8, there's going to be a 4 over here. 3 2 times 6 plus 4, that's going to be a 10, and which makes it a 5. But one thing we ignored was the oxygen over here. I'm so sorry, we ignored one thing, the oxygen over here. So it's going to be, wait a sec, we have just, so we need 13. So what we're going to do is we're going to put 6 over here. 6 2 times 12 and 13. So we're done with it. I'm sorry for this. 4 over here and a 10, so 5. So we're done with it. ठीक है, यहाँ पे हमें 6 ही चाहिए थी. So option A is correct. I'm so sorry for this. Option A is going to be correct. I just missed out this oxygen over here. That's very important. Don't miss it out, because with this oxygen you have this oxygen as well. So that's option A is going to be correct. Let's figure out for propanol as well. It might be helpful. So how many oxygen? We need 10. 1 we have over here, so we need a 9 over here. We're going to put 9 upon 2, which makes it get multiplied by 2. 2 over here, 9 over here, and 6 over here, and 8 over here. So we need 9 for complete combustion of propane 1 and 2-ol for 2 moles, and for 2 moles we need 9. So for 1 mole we need 4.5. So definitely not this. And so let's move on to the next question, which says that the diagram shows the partial structure of a polymer. That's the polymer. Which pair of reagents is used to form this polymer? Let's figure it out what it is. Okay, so we have a CN over here. We have 2 different types of monomers. Let's break down from here. We have a N and C over here, a C, C, N on this side. Okay, So the polymer is gonna be, let's figure out what happened over here. अब देखें, you just need to simply think about this कि यहाँ पे एक ऑक्सीजन होएगा और यहाँ पे एक OH होएगा और यहाँ पे एक H होएगा to form water, ठीक है? So it has to be C double bond O H, and then you must have over here a bond is formed. Wait a sec. देखिए यहाँ पे एक बॉन्ड फॉर्म हुआ है ना. सो दिस इज़ एमाइड लिंकेज. तो यहाँ पे एक H होएगा, N होएगा और H होएगा, ठीक है. फिर यहाँ पे ये होएगा, दिस गोना बी एन N एंड अगेन एन NH. ओके, यहाँ पे भी एक H होना चाहिए, यहाँ पे एक O होना चाहिए. सो लेट्स सी टुवर्ड्स इट कि कौन सा है. यहाँ पे अगेन एक एमाइड लिंकेज है, ये भी एक एमाइड लिंकेज है. ब्रेक इट डाउन फ्रॉम द लिंकेजेस एंड गोना फिगर इट आउट. ओके, यहाँ से तो करेक्ट है बट यहाँ से इनकरेक्ट है. यहाँ पे भी हमें एक C चाहिए. इस वाले को देखिए, यहाँ से तो करेक्ट है, यहाँ से भी करेक्ट है. सो यहाँ से ये वाला भी करेक्ट है, ये वाला भी करेक्ट है. तो कॉम्पिटिशन इज़ बिटवीन B एंड ऑप्शन D. अब अपने इस N वाली चीज़ को देखें. N वाली चीज़ के इस साइड पे N होना चाहिए, इस साइड पे भी N होना चाहिए, ठीक है. इस साइड पे N होना चाहिए, इस साइड पे भी N होना चाहिए, इस साइड पे N, इस साइड पे भी N. सिंपल. D. आपने सिर्फ इनके साइड्स पे देखना था, ये और दूसरे वाले की साइड पे C और C था. सो दैट वाज व्हाट यू हैड टू लुक एट एंड इट मेक्स इट यहाँ पे भी NN और CC. सो simple. Moving on to question 38, which says a student measures the rate at which the fixed mass of magnesium reacts with the fixed volume of dilute hydrochloric acid. Okay, you have a fixed mass of magnesium, you have fixed mass of dilute hydrochloric acid. You're measuring the rate by measuring the volume of which gas is going to be produced. You have a metal plus acid that's going to produce hydrogen gas. Which additional piece of apparatus are required for this experiment? I guess to measure rate, you need your time as well. So a stopwatch is very important. So let's highlight the stopwatch, a stopwatch, and a stopwatch. Okay, what else do we need? So we have a fixed mass. So I guess to measure a fixed mass of magnesium, we must require a balance as well. So a balance, and now the only thing is a thermometer and a measuring cylinder. Secondly, we have a fixed mass and a fixed volume. To measure a fixed volume, we should require a measuring cylinder, not a thermometer, which makes option A to be correct. Because we just had to look at what we have to measure. From balance, we had to measure the fixed mass of magnesium. From measuring cylinder, we had to measure fixed volume. From stopwatch, we had to measure the time for the rate. 39, which says 2 titrations of dilute hydrochloric acid with aqueous sodium hydroxide are done using 2 different indicators, methyl orange and thermophthalene. The equation for the reaction is shown. Okay, a long question. So let's just highlight the important stuff we are getting. There are 2 titrations that are being performed of dilute hydrochloric acid with aqueous sodium hydroxide. We're using 2 different indicators. In one, we're using methyl orange, in one, thermophthalene. The equation for the reaction is given using a volumetric pipette. This is the volume of dilute hydrochloric acid that we're going to add in the conical flask, and a few drops of the indicator. Aqueous sodium hydroxide is added from the burette in dilute hydrochloric acid as the endpoint is reached. Okay, we don't know the volume right now, but let's just see. The endpoint of the titration with each indicator occurs to be this of aqueous sodium hydroxide is added. Okay, now the endpoint is same for both the indicators. Which statement about this experiment is correct? Now what is this endpoint telling you? This 23.6 tells you how much volume are you taking from this burette. Means 23.6 cm cube is being utilized from this burette, okay, of NaOH. The methyl orange changes color from red to yellow. Okay, let's figure it out. First, it was in acid. Methyl orange is red. When alkali was added, which was NaOH, okay, it turned yellow. Okay, so that's correct. Option 1 is correct. The thermophthalene changes color from blue to colorless. In acid, thermophthalene is colorless, and in alkali, which is NaOH, it had to be blue. So it was from colorless to blue, not from blue to colorless. Very confusing option. 3.1, the dilute hydrochloric acid is less concentrated than the aqueous sodium hydroxide. That's what you're going to get from the equation. 1 mole of this should react with 1 mole of this. So both of their volumes should be equal. Equal volume of HCl. If they have equal concentration, then equal volume of HCl must react with equal volume of NaOH. But what's happening over here with 25 cm cube of hydrochloric acid, your 23.6 cm cube of aqueous sodium hydroxide is added. So sodium hydroxide should be the dilute hydrochloric acid should be more concentrated. Why it should be more concentrated? देखें, आपके 1 मोल के साथ 1 मोल रिएक्ट करना चाहिए, बट यहाँ पे आपके 25 के साथ 23.6 रिएक्ट कर रहे हैं NaOH का, और यहाँ पे HCl है. मतलब ये ज़्यादा कॉन्सेंट्रेटेड है बिकॉज इसका कम वॉल्यूम यूज़ हो रहा है टू न्यूट्रलाइज. ठीक है, द सेम अमाउंट. ठीक है, अगर इसका भी 23.6 होता है देन दे वुड हैव बीन ऑफ इक्वल कॉन्सेंट्रेशंस, बट राइट नाउ NaOH इज़ मोर कॉन्सेंट्रेटेड एंड HCl इज़ लेस कॉन्सेंट्रेटेड बिकॉज देखें less of it is being used to neutralize this. Less of it being used means it's more powerful, it's more strong. That's the key concept. So 3 is going to be correct. Hydrochloric acid is less concentrated, which makes option 1 and 3 to be correct. What is used to separate a solid mixture of copper? You have a solid mixture of copper powder and sodium chloride to obtain pure solid samples of each compound. First, what's going to happen is, let's just draw a diagram. You have solid mixture of copper, you have your and sodium chloride to obtain pure solid samples. You have a solid mixture. So what you're going to do is, देखें ये आपका copper है, ये NaCl है. So what you're going to do, add water or a suitable solvent. NaCl will dissolve, then you filter out the copper, and then the remaining mixture is crystallized. So 1, 3 and 4 are what you're going to perform. So it's going to be option C. I guess that was simple. Simply you have to take a container, in it you had copper and you had NaCl, then you had to add water into it. NaCl would dissolve, you filter out the copper on this, and the remaining mixture of NaCl is crystallized to get NaCl crystals. And we're done with this paper. I hope you liked it, and if you did like it, subscribe to the channel, and that's going to mean a lot. Bye bye.